Introducing ThermoCalc 2024A, released in December 2023. This release features several updates to the additive manufacturing module, a new parallel coordinates plot type for materials design, and 4 new property models for a variety of applications. This release also includes 6 new databases, including our first ever database for molten salts. Additionally, electrical conductivity of ionic liquids has been added to the TCOX database, meaning that the database can now calculate electrical conductivity and electrical resistivity for any slag composition. The Additive Manufacturing Module, or AM module, received 2 major new features in this release and is now available in TC Python. A keyhole model has been introduced in the AM module. In additive manufacturing, when the laser beam intensity is high, which is often done to increase productivity, evaporation of liquid metal creates a recoil pressure that pushes down the liquid to form a cavity, which is called a keyhole. The additive manufacturing module now includes a model that computes the keyhole shape and corresponding mesh that is used for the steady-state simulation. The model also includes the effect of multiple reflections of the laser beam on the keyhole walls. A heat source calibration option has been added to the AM module in order to improve the ability to predict the melt pool size under various process conditions. This new feature allows users to import experimental melt pool data for a range of processing parameters. Users can then calibrate the heat source parameters to match the experimental data for your material and processing conditions. Once you have finished the optimization, you can plot the heat calibration parameters and the melt pool dimensions as a function of energy density, which we define as power divided by scan speed, and select a function for each heat source parameter. The heat source functions can then be saved as a user-defined heat source, which will then be available from the heat source menu. 2 examples are included in the software demonstrating this new feature, and one can be run without a license for the AM module. The Additive Manufacturing module is now available in TC Python and includes nearly all the functionality included in ThermoCalc. This edition allows users to easily perform simulations over a large range of process parameters and to produce printability maps for when defects like lack of fusion, keyholing, and balling will occur. 6 new examples are included in TC Python demonstrating the AM module. Users who do not have a license for the AM module can run AM examples 1 through 4 and 6. Another valuable addition for additive manufacturing users, and for those of you working with casting, is the new columnar to equiaxed transition property model. The property model calculates the fraction of equiaxed grains that correlates with a certain solidification condition, specifically thermal gradient and solidification growth rate. This provides valuable information on the solidification microstructure. 3 new examples are included in the release demonstrating this new model, as shown on the screen. For those working with materials design, a new parallel coordinates plot type is introduced in the Property Model Calculator. The parallel coordinates plot is useful when interpreting multidimensional data and to compare how different parameters affect each other. This is especially useful in materials design after performing a batch or uncertainty set of evaluations when multiple inputs are varied at the same time and multiple model outputs are given as a result. The new plot type is used with the Property Model Calculator and either the grid, batch, or uncertainty calculation types. One new example uses this new plot type. A new Scheil property model is available for all users of ThermoCalc. This new property model is essentially the same as the Scheil calculator already included in the software, but implementing Scheil as a property model allows users to benefit from the additional calculation types available in the Property Model Calculator. including multi-axis grid, min-max, uncertainty, and batch. The crack susceptibility coefficient property model received 2 new models in this release. In addition to the original Klein and Davies model, you can now select Cow or Easton models. The model also received additional Scheil settings. For example, users can now select Scheil with back diffusion in primary phase or Scheil with solute trapping, in addition to classic Scheil. The advanced Scheil options have also been expanded in the property model. The intrinsic strength model has been completely overhauled in order to improve the yield strength model. Previously, intrinsic strength was only calculated per element and only for FCC, BCC, and HCP. Now the model formulation corresponds to a surface of reference with end members. The change enables accurate modeling of the strengthening effect to interstitial elements and stoichiometric and non-stoichiometric compounds, in addition to solid solution phases. For example, it is now possible to calculate yield strength for materials with a significant fraction of hard phases, such as carbides, embedded in a soft matrix. The steel model library introduces one new property model, martensitic steel strength, which calculates the yield strength and/or hardness of martensitic steels. The new model includes one new example showing users how to use the model. The nickel model library also introduces a new property model, strain age cracking, which is used in applications related to welding and additively manufactured components where there are interface strains between gamma prime and the matrix. A new example is available demonstrating this new model. The example also uses the new parallel coordinates plot type discussed earlier. The console mode version of Dictra now allows users to add a stop criteria to their simulations, which means that users can add an alternative criteria instead of the final time to terminate the simulation. For example, for a carburization simulation, you can terminate the calculation when the carbon content at a certain depth has reached the desired value. A new Remove Stop Criteria command is also available to remove the stop criteria. Note that this feature is not available in the graphical mode. The precipitation module TC Prisma adds the ability to convert 3-dimensional distribution to 2-dimensional distribution, which allows users to compare simulations with experimental data. Users can calculate the 2-dimensional size distribution, number density distribution, and normalized number density distribution. The 2-dimensional mean radius can also be calculated. To learn more about this new feature, users can run the new example included in your software, or read the release notes, which go into detail about this new feature. ThermoCalc 2024A includes 6 new databases, including the introduction of our first ever database for molten salts applications, TC Salt 1. TC Salt 1 is a completely new thermodynamic database for molten salts. The database can be used for a variety of applications, especially for processes involved with recycling aluminum, where fluxes are used. The database covers the most common fluxes, and you can study the fluxability to dissolve inclusions like oxides, removal of unwanted elements in the AI melt, and how this varies with flux composition and temperature. The database can also be used to understand high-temperature corrosion, where molten salts can destroy the corrosion resistance. TC Salt 1 includes 11 elements, 57 pseudo-binary systems, 41 pseudo-ternary systems, and 154 phases. A new version of our metal oxide solutions database, TCOX13, is available with the 2024A release. The database adds electrical conductivity for ionic liquid, which means that it is now possible to predict electrical conductivity and electrical resistivity for any slag composition. The database also adds one new system and many reassessed systems. The 2024A release also includes a new version of our High Entropy Alloys database, TCHEA7. The database includes 7 new binary systems, 2 new ternary systems, reassessment of 5 phases in over 100 systems, and a reassessment of surface tension based on a different model. A new version of our aluminum-based alloys database is also available with the 2024A release, TCAL9. The database adds 4 new elements, 38 new binary systems, and 11 new ternary systems. Additionally, full gas descriptions are added and selected by default, so the database can now be fully used with the additive manufacturing module. The Companion Mobilities database, MOB-AL8, is updated to correspond to TCAL9. This release also includes updates to the copper-based alloys database, TCCU6, and to 4 of our demo databases, as listed on the screen. To learn more about all of the new improvements, features, upgrades, and databases in ThermoCalc 2024A, visit the release news page on our website at thermocalc.com/release news.